Hello, ladies and gentlemen, and welcome to another episode on Strategic Risk. My name is Lloyd Dearness, and I am a cybersecurity consultant. I am also considered a subject matter expert in the field of strategic risk, and I have a number of other certifications and experience across a wide range of topics that are in one way, shape, or form related to information technology, operational technology, cloud services, along with the associated business processes and services. And today I want to talk about something that is often considered to be just in the domain of those other business services and not necessarily associated with cybersecurity or risk. In fact, there is an association. However, let me just take a moment and give you a little bit of highlight on my background so you understand where I'm coming from the 30,000-foot view, so to speak. In addition to the training and certifications that I have in the fields I just mentioned, I am a Lean Six Sigma black belt. Now, for those of you who are not familiar with that, Lean is a discipline often considered part of the Agile family of disciplines that strives to improve efficiency by reducing waste. And it reduces the waste in a number of specific areas, and I won't get into that today because that's fodder for another episode, frankly. Six Sigma is a discipline that takes statistical process control and other tools to improve quality. In fact, improving it to very high levels, holding it up to very high standards. So the marriage of the lean principles and the reduction in waste that you get through that with the hard math, so to speak, the statistical process values that you get when you're doing a Six Sigma analysis of something, collectively is known as Lean Six Sigma. I am a black belt. That is the highest level within the, I'll call it the functional colored belts of the Six Sigma program. There are higher levels in terms of training and things like that. But I just wanted to give you that background so that you understand where I'm coming from, so to speak. Now, if you work for a small private business, if you work for a large private business, a large enterprise, if you work for an NGO, a non-governmental organization, if you work for a nonprofit or for-profit in some other category, you may not be able to directly relate to what I'm going to tell you, but I'm going to try to broaden the topic a bit so that it has relevance for you as well. The reason why I have a little bit of difficulty doing this is because, without a doubt, the biggest issue that I have seen occurs in the federal government sector and sometimes at a state or local government level. It still occurs in these other organizations I talked about in the private sector, but it's not quite as bad. And when it happens, people are a little bit faster to respond to it. So I want to talk about quality, and I want to talk about quality from the standpoint of how it's implemented. So let me take a step back. Imagine I'm walking into a federal agency as a consultant, as a contractor, not as a federal employee, and I'm talking to them about the various programs that they're doing. And let's just say that the part of the agency that I'm dealing with here is a software development shop. In other words, they're writing code. They're developing new programs for this agency. And in talking with the people there and talking about the processes that they're using to write the code and roll it out, someone mentions QA. And I said, great, you have a QA program. And they say, yes, we do. I'd say, I'd love to hear about it. So they explained to me that in the what we call the development stack, in the place where the code is written initially by the developers, once they have committed that code and it is ready to be examined to make sure that it meets all the requirements, it goes into a testing environment, sometimes called the testing stack. In many of these organizations, they have taken to calling that testing stack the QA stack, the quality assurance stack. Well, right there is a problem, because quality assurance is being treated as a stage gate or a process gate. It's a place that you get to after the code has been written initially, and when you do the tests that you're doing in this testing environment, you're deciding whether or not it meets the requirements and whether or not some piece of it or the entire thing needs to be kicked back to the developers before it can go any further. Testing has to happen, absolutely. But testing is not QA. It's not quality assurance. It's something else. It's called quality control. And you may say, quality assurance, quality control, it's just semantics. Well, it's important to understand exactly what these terms mean and why there are two different terms in use here. In order to do that, however, we have to go back a little bit to the development area where the developers are writing their code initially. They're writing their code in order to satisfy certain requirements. Generally speaking, we look at those in terms of functional requirements. So, for example, we have a cell phone and we say that it must be able to make phone calls. We want an application built into it that will allow it to take pictures. We want it to be able to record incoming calls in the sense of voicemail, and so on. So we have all these functionality requirements that we've delineated, and the developers will build that in by writing the code that they need to write to do this. However, what about quality at that point? Well, you don't just tack quality on at the end. What you do is when those requirements are being drafted before a single line of code is being written, you will sit down and you will look at those functional requirements and you will determine the quality standard or the quality baseline that you want the functional requirements to adhere to. So, for example, the resolution of a camera might be considered a quality standard or a benchmark, that it is of a certain high, or in some cases you may deliberately make it a certain low resolution for other reasons, dealing with efficiency and bandwidth and so on. The reality is that you are not saying how you're going to check for that at this point. You're simply describing what those quality requirements are. Quality requirements are not the same as the functional performance requirements. Quality requirements are what they fall into a group of requirements known as non-functional requirements. For those of you who have a background in cybersecurity, you know that security requirements are considered non-functional requirements. So here's just one more type of that, and it meets the same general idea in that you have to have it, but it doesn't change what the functionality is going to be. It simply changes the standard or the level that the functionality is going to perform at. And in the case of cybersecurity, non-functional requirements, what you need to do to protect that. So we take that standard, that baseline of quality, and then we figure out what we have to do with the developers to ensure that the quality is built in to the code. That's quality assurance, that's QA. Now, once the code is written, we want to test to make sure that all of those benchmarks that we came up with, those non-functional quality requirements, are actually ending up in the code, and that the steps that we have been taking with quality assurance are adequate. Because if we do a test and we find that something is missing, we have to go back and we have to look at the quality assurance effort, and we have to say, what did we miss here? Why didn't this get fixed on the as it was being built? Or how is it possible that something was wrong and still managed to get implemented into the design? Those are the kind of questions that you're going to be able to ask at that point. Now, when it comes to quality control, and testing, you have, in addition to the very specific types of tests that you're required to perform on something, you are going to have a standard where you have a type of test. You're going to have, for example, a unit test where you are just testing the specific little component or the specific little piece or unit that you have developed. You have system tests, which, as the name implies, test the overall system, functionality, and so on. You have other types of tests. You have performance tests, you have security tests, and on and on and on. You have regression testing where you look to see if what you've done is going to break something else that it's connected to. All of these different types of tests fall into two broad categories of the type of testing. And very often in the federal government sector, you'll hear this referred to as IV and V. The I stands for independent because you want the tester to be someone from outside of the initial organization, someone from outside of the organization that built this thing and did the initial testing. Independent, verification, and validation. I, V, and V. What's happening is there's some level of verification testing, but there is rarely, if ever, validation testing, because they don't know how to establish the validation model. In other words, they don't know how to figure out how to validate this thing. So I'll give you an example of why this is important, and it may help to illustrate why it's difficult for certain agencies, certain organizations to implement it. And with this example, this is a story, it's fiction, something I'm making up to illustrate a point, but I will use a private business, a relatively small private business, to make the point, to give you the environment. So we have a company that is based in the American Southwest, and its geographic location is important because the American Southwest is, generally speaking, a warm and dry climate environment. And this company has come up with a design for a smoke detector that people can put in their homes or businesses. And the smoke detector design that they've come up with is innovative. It's less expensive to develop. It has more resiliency, so they believe that it will last longer. And because it's less expensive, they believe that they have a niche in the market now that they can approach and exploit, because they can build this thing, they can market it for less money than the competitors, but it will be of a higher quality standard. They go ahead with the design, they test it extensively at their facilities, they may even have some sort of a laboratory that they test this thing in, and they have marketing and salespeople, and they put together a sales and marketing program, and they find distributors, and they arrange for the logistics, the transportation of the product. They ensure that their pipeline, their source pipeline for suppliers is good, and everything is going down very smoothly. They're putting this thing out there, it's hitting the store shelves, and it is selling. Whether they do any advertising or it's word of mouth or whatever, the thing is selling, and it's selling well, and they're making money, and everybody's happy. They have some accolades that come back, situations where there was smoke or a fire started someplace, and the detector went off as it was designed to do, and it saved the lives, it saved maybe the structure because it sounded early enough that they were able to get in there and put the fire out, things like that. Everything's great. So because it's working so well, it starts to get a reputation, a positive reputation, and today, with all of the various social media and the various sites that are used for people can put their ratings and their evaluations on products online, the internet being a global phenomena, word spreads. And they start getting orders from other parts of the United States, maybe even other parts of the world. Good thing on the surface, especially because they have gone from the push model of marketing, where they are aggressively selling their product and touting its features and so on, to the pull model, where customers on their own are hearing about their product, perhaps from other customers, and they are coming in and reaching. They are pulling the product in from the manufacturer. Again, this is great. However, over time, a year, 2 years go by, and they start getting some reports that buildings were catching fire and perhaps burning down, perhaps there was some injury or loss of life, and their smoke detector apparently didn't work. It never sounded the alarm. So it takes a while, but they eventually get a couple of these detectors in, and these are not ones that were sold in their local environment, in their local market. These were ones that were sold elsewhere in the country. Let's say instead of the American Southwest, it was the American Northwest, a place like Washington State or Oregon where there's a very damp, humid environment along the coast. In fact, it's some of the wettest areas in the country. So they open up these detectors and they examine them, and the first thing they notice is that there is moisture corrosion damage in the electronics. These things corroded because they were in a very wet, moist environment. So the company starts to think about this and they say, you know what, we never really tested for long-term performance in those environments. We tested here, locally, in this environment where it's very dry and corrosion was never an issue. However, we didn't anticipate that the demand would spread, people would be pulling our product in from other environments, and it just never occurred to us to do that type of testing. That type of testing is validation testing. That's where you, after you've verified that the product is meeting all of your functional and non-functional requirements, now you want to make sure that the thing is going to perform in whatever environment it's supposed to perform in. Now, this is fiction. The story is, just made it up for illustration purposes. But what could they have done? Well, they could have anticipated that someday their market might expand. And so they could have built a laboratory facility that would simulate those environments, and they could have done long-term testing. They could have sent the product out with a caveat that it may not work or it may corrode, and people need to check it on a regular basis. They could have possibly redesigned the product to seal it in some way so that the corrosion wasn't necessarily going to be an issue anymore. There's a variety of approaches that they could have taken to it if they had even thought it through. That brainstorming that it takes to think that way is something that unfortunately is sadly lacking in a lot of organizations. But that's the essence of good validation testing. So, bringing it all home, an organization, if they are concerned about quality, they have to have whatever the requirements are documented alongside the non-functional requirements that include quality requirements and security requirements. Those become benchmarks or standards that they have to adhere to. With that in mind, they have to look at the production process, whether it's writing code or it's building a device, a physical hard device like this phone, or if it is anything, any process, even if it's a service that they're offering, if it's a human process where somebody is going to be doing some effort on behalf of someone else or the customer, whatever that is, they have to figure out how to assure that it is done in accordance with the quality benchmarks and standards that they've established. That's QA. Then they have to do the QC, the quality control testing, to see whether or not all of these things are actually working. And one of the things that they're looking at to see if it's working is their quality assurance program. They're evaluating it, because if they find problems, that means that something is missing or wrong in their quality assurance. And when it comes to quality control, we have to look at it. Well, with both QA and QC, but specifically with QC, we have to ensure that we open our minds up, we think about all of the different possibilities that we can brainstorm around, and if the environment changes, if our market changes or something else changes, we have to sit down, we have to go back to the drawing board, and we have to reevaluate what type of validation testing is going to be necessary. So that's it for today. Thank you for watching. I hope that you understand that quality, whether it be quality benchmarks, quality assurance, quality control, are essential not only from a cybersecurity standpoint, because they non-functional requirements just like security, but also from the standpoint of business functionality, business survivability. If you have any comments or questions, my contact information is in my LinkedIn profile, and I look forward to hearing from you. Thank you again.